Okay, so we're going to pick a vehicle, and in this example, we're going to modify the covet. And the path where the vehicles are going to be saved is wherever your Steam library is. If you have BeamNG through some other source other than Steam, I don't know what to tell you. Steam apps common BeamNG.drive content vehicles. And there's a whole bunch of zip files in here, right? And in this example, we're going to do the covet. Now, what you also need to do is go to the mods unpacked area. So, and this is going to be in your app data folder. It's going to be, users, username, app data, local, BeamNG.drive, and then this tree underneath it. And whatever version you're running, you'll use that version folder. Then mods. If there is no unpacked folder, you will need to create it. If there's no covet modded folder, there won't be. You will need to create that. Inside that, you'll create a vehicles folder, and inside vehicles, a covet modded folder. From there, we're going to take that zip file and we're going to go into the vehicles subfolder in the zip file, the covet subfolder in the zip file, and we're going to select all. Just a Control A and copy it over to your covet modded folder. Now, that is the first step. And you're thinking, oh wow, that's a lot for a first step. That's the first step. The next step is we're going to go to info.json or in JSON. And JSON is it's JavaScript object notation. It's got some added. JBEAM is basically JSON, but in this case, JSON are config files. And you look in this directory, what you copied out of the zip. There's a lot of files. There's graphics here that make up the different liveries and details on the car. These JBeam files we're going to get into in just a moment. But then you also have JSON files, JSON, that are configuration files. And info.json is what we want to look at real quick. Now, you can probably see I'm going to increase the font size for the sake of video. Right up here at the very top of the file, BeamNG is the author, body style hatchback, shirt brand, Ibishu fine, country, Japan, derby class, leave that alone, but name, covet, and then I've added space, modded, and that is the label that you will see in game in the vehicle selector. So that's useful to be able to identify it away from the vanilla vehicle. Save that. Okay. Now, we're at the step where we can open BeamNG. And verify that we see the modded vehicle. This is, I know, there's a lot of work just to duplicate a vanilla vehicle, but these are the steps to creating your own unique mod based on a vanilla vehicle. I like to go to the small grid map. It's a little bit less resource intensive. There's no trees, there's no nothing. It's just flat space and your car. And that's important because of some of the tools we'll be using in just a few minutes. And here we have my default car that I've modified, but we're more interested in the one that we're modifying today, which is the Ibishu Covet. We see the Ibishu Covet modded. Now I've gone ahead and made a demonstrator car. The only difference with the demonstrator car is that it has no engine and no hood. And that will make sense in just a moment. Now, it's time for a quick word about JBeam, because that's what we're going to be modifying. And JBeam, like I said, it's JSON. It's basically JSON, JavaScript object notation, but it has some added goodies that make vehicle development, if not just easier, possible. Cars in BeamNG are made up of a beam mesh. Now, I'm going to do something real quick. I'm going to make the car visible, and now you can see the beam mesh. Now what that beam mesh is, it's a simplified structure. This pretty model that we normally see is kind of wrapped around that simplified structure, and all of the physics calculations in the game happen on that physics structure. If you use the node grabber, you're not grabbing the pretty model. You're grabbing the node that the beam is attached to. And you can see once beams are broken, their link is not lost in the simulation, but it's no longer calculated. Because I could just rip the bumper or front valence off of the demonstrator car. Now, beams, so nodes are a 3D point with XYZ coordinates and a weight or mass. Beams are the lines that connect them together. And then we also have, we're going to get rid of the beam display. There we go. Triangles. And triangles are what provide a surface in between the nodes and beams for collision detection. And you can see here we have a special surface for the tires, but the body is made up of collision triangles. And you can see that the body even includes collision triangles for the hood that is not on the vehicle. And this is not uncommon in JBEAM to have collision triangles where they might not always make sense. But by and large, your triangle structure, which is made up out of those nodes and beams, will match the overall shape of the vehicle. Now, as I said, nodes have weight or mass, and beams have strength and springiness. Triangles are a little bit beyond what we're really going to talk about, but they're useful to know that they're there. There are special beams that are sliding beams, and those are used sometimes in suspension components to allow motion. There are hydraulic actuator beams. Those are sometimes used to affect the steering. But really, we're just going to focus on the basic structural stuff and how you can do offsets and variables and maybe a few other interesting little things. So if you wanted to build from scratch, like an A-arm and McPherson strut style suspension system, you would use nodes for your ball joints and spring perches and damper mounts. You would then use beams for the control arms, your springs, your dampers, and the variables for each of these items would then, of course, define your spring rate and damping and so on. And then the geometry, of course, would affect its performance much like a real suspension system. That's one of the things that we love about BeamNG is that it simulates pretty accurately what the different subsystems of a car should do because they're defined subsystem by subsystem. Now, the developer console is something else I want to touch on. It's handy if you goof something up. If you create a syntax error in JBEAM and try to reload the vehicle, this can be helpful, and it's accessed via the tilde key. This can be helpful for finding where you have a syntax error. Now, we can see the JBEAM structure, right? We can see the JBEAM file. Well, like I said, the JBEAM file is JSON. We already have modified one JSON file. That wasn't any sort of a tricky thing to do. It was plain text. We can open it in Notepad. So let's open the front suspension in Notepad. Oh. We can see X, Y, and Z coordinates. We can see pairings between those nodes that are defined. Here we have a node, X, Y, and Z coordinates, what group or part of the car it associates with. There's lots of useful details in here, even if you're not willing to pour through and fully understand how the file format works. It's useful to know kind of what you're looking at. And so you have X, Y, and Z coordinates, those make up the nodes. And then you have pairings of beams, and those pairings of nodes, and those make up beams. Again, triangles are a bit out of scope for this, so we're not going to get into that. okay, cool. What do we do with that information? There's really no way I'm going to figure out without using the node viewer what nodes are part of the suspension, what nodes are part of the car body, and so on in the simulator. That's impossible. Now I could probably search because there are comments, like this is a comment, front running gear. But unless I'm the developer that was building this car and working on this model for any length of time, I'm probably not going to have any idea what to guess other than various car parts. So how do I work with this file format and in a 3D context? Because that's what we're doing in the simulator. I want to be able to visualize that in an editor. Well, it turns out there is an editor for that. I'm going to leave it on this for just a moment so you can jot this down. The repository is Rormasa. Sorry if I mispronounced that. And they wrote Node Beam Editor. And it is a simple utility for building and editing BeamNG and rigs of rods node beam structures. It's still in an early stage of development. There are some quirks with this tool, but it's totally worth using in my opinion because, and you'll see this in just a moment, it gives you that 3D editor interface for JBeam. Now that being said, we have this JBeam file. We know that it makes up this 3D structure stuff. This is that tool that I just showed you in the browser window on GitHub. And this is the Covet's front suspension. And it's as simple as just going to open JBeam and hunting down the file in your modded Covet directory or folder and opening it. And then once you've opened it, then you kind of have to look at it and go, well, this is the origin, and this direction to the left from the default view, the left of origin is forward. So we're looking at the front of it at this right now. Okay, cool. That's the front of it. Well, I want to see in the game what that looks like. So you can go into the vehicle config and you can make things invisible. Just click on the little eyeball. I just made the whole car invisible by clicking on the unibody, because everything is a subsystem of the unibody in this car. Now I go down to the subsystem I'm working on, the front suspension. Everything below the front suspension in the tree, everything that is either a component of or a subsystem connected to the front suspension, is now visible with nothing cluttering. And I'm going to expand that a little bit and expand that, and I'm going to hide the brakes and the tires and wheels. So this is front suspension with hubs. In fact, let's hide the hubs for a moment. There we go. The shape kind of makes a little more sense now. The shape in the editor, you have these longitudinal torsion rods, lower control arm, strut, upper control arm, steering knuckle, and then the hub would go through the steering knuckle there. There's your torsion bars. There's a stiffener there that goes to the torsion bar, and your suspension and control arm basically right there. Now, I want to add a strut brace. And a strut brace goes from that upper mount over to that upper mount, and it stiffens up the chassis. Well, okay, cool, that's super easy, except in this tool, and this is one of the quirks that is key about this tool, is you have to make sure of where your cursor position is before you start creating stuff. So you can see my cursor is at the top of the document. I want to find in the document where I'm going to put these. And I know that I'm going to create a beam because the nodes already exist. I'm going to put a beam between these two nodes. So now I'm going to go down to beams, and we can see beam ID1, ID2, front subframe, main shape, crossing, steering box, and there's other various beams and definitions for beams in this section. You'll see there's also beam spring, beam damp, beam deform, and so on. And these are various beams where they've defined a brake limit, such as engine mounts, subframe to body mounts, because in a serious enough accident, those are failure points. The subframe structure and suspension structure of the vehicle, while deformed, doesn't typically separate into its subsystems in an accident, but these mounts do separate. The subframe can become detached from the body and will, in some cases, go under the body structure further back in a serious head-on collision. That's how, in this JBEAM, we define where those breakpoints are going to happen, is by giving them different amounts of deform and strength values. Now, we're going to find a good spot, which I'm going to say is right here before it starts doing the steering box. Tab 3 times, 2 slashes to add a comment, upper brace for our comment. Now, we have our cursor in the right position. We're going to go to Beams, Add Single, click this node, and then click that node. And when you look over at the text, we see that it has created the beam for us. It's that simple. We've now created a beam across the hood. Now again, we're going to look at the whole car. Let's get in position. We can clearly see there is no beam going directly across the top of the engine compartment, stiffening up the suspension. So we will save our JBEAM. We'll go back to the simulator. In the simulator, you can hit Control R to reload the whole vehicle, JBEAM and all. And now we have coming out right there, that green line going across to here. Ta-da! We just modified the JBEAM structure of the car. And now this particular covet will suffer a little bit less with unibody deformation during hard cornering or rallying or whatever crazy things we want to do with it. We've also just done something that's already available in the parts list for this car. There's a strut brace available when you build one out, how you want to build it out, and the options in the game. So let's try something that's a little more visually rewarding. We're going to stance and slam the car. Now, you might have noticed at the top of this suspension front, there's some variables defined, right? Here's a section called variables, and these variables are defined. Camber, caster, and track offset. Well, let's get rid of our beam view, and let's look at the vehicle config. When you go into tuning, in front suspension, you will see camber, caster, toe adjustment, camber, caster, and wheel offset. Now, wheel offset is track offset. Camber is the camber adjustment, and caster is the caster adjustment. Well, to stance a car, you have to set the camber way in. That's the look that they go for. And let's get the camera situated so that we can see if there is any camber change between negative 100% and 100%. Not much of a noticeable one. Oh, that's rear. There we go, front. And then all the way out. It's not a lot of difference. So what we're going to do is we can close the beam editor. This is going to be easier to do in Notepad. I'm going to open this. And camber, the default number is the first. The minimum and maximum are the next two values. We want the minimum to be 0.5 instead of 0.9, and we want the maximum to be 1.5 instead of 1. Now, Control R to reload. We saved this. We reload, front camber, all the way in. Sometimes we do things that break part of the car. Doesn't seem to have actually broken it, but we now have an aggressively stanced front camber. That's a little less aggressive. Let's go about there. Cool. Now, you know what? Let's go wild. Thump. So we've, just in changing two values here, the minimum and maximum values here, have opened up the range of the ability to do something that it's a little silly. I don't think it would hold up for long, just due to the odd angle it's putting things like the CV axle at. And I don't know. I don't have an engine in this one. We'll do that at the end. Put an engine in and test our crazy car. Now, that's cool. You know what would be even cooler? Let's slam it too. So I did that real quick, but what I did was I copied track offset front, and I just made it again. Now I'm going to replace track offset with ride height. And we're going to go over here, and we're going to say ride height. That's the title of it. And okay. And this is for the subcategory front, ride height front, all of that, right? What we're going to do next is find where that's used. And I'll give you a hint because it took me a couple of minutes to find it too. It's in hubs. The front hub is considered a subsystem separate from the suspension, or subsystem under the suspension in this car. So we're going to find where their track offset front is being used. And it's being used for the X value on the front wheels. The Y value is a static value. And then we're going to set ride height, in quotes, for the Z value. Now you'll find this 3 times because there are 3 hubs defined. There's the center lug hub, the 5 lug hub, and the 4 lug hub, all defined in the Covet hubs front JBEAM file. So now that we've set that up, we have a variable in the suspension file for our ride height. Now, it is lowercase r, capital H in my example, and they are case sensitive. So it has to be lowercase r, capital H here as well. We save both of our JBEAM files. We go back to the sim, hit Control R. And watch the front wheels fly off. Now, lots of fun things happen when we start messing with the numbers in the car. The numbers that make up the car. And that's totally fine because what we're going to do is we're going to now play with the ride height. We need to adjust the variable. The value is wrong. Let's look at the rear suspension Z value, or rear hub, sorry. So what we've done is we've told the front hubs to be offset by a certain amount. And that would be fine, except that the amount we've selected is based on the track width, and that messed it up pretty bad. So we're going to go to, the default should be 0.288. And in the front suspension where we define that, we can say ride height front, the default is 0.288. The minimum is 0.0. The maximum is 0.3. 0.4. Control R to reload. Okay. Sometimes we have to reopen the menu as well to see the range change on here. Well, that's interesting. Okay. Sometimes when you screw them up like this, the only thing to do is to go to the source one, and we're just going to look at what the default value was. Hubs front. .288. Okay. Oh. Hmm. 'Track width front, track width front. Yeah, that's where I goofed. When I call the variable in the hubs document, I forgot the underscore F. Yep, that was the problem. Now they're back on the right place. I was calling a variable that doesn't exist, so who knows what garbage value that was getting. Let's slam it. Okay. So that means that we do need to make our value a little bit wider, or range a little bit wider. Ride height front, default 288, minimum 0, maximum 46, 0.46 I should say. There we go. Ha! See? That's another gotcha. And I saw that with a different one as well. It's inverted. Oh, and there we go. It is slammed. Let's do the rear. I mean, I'm on a roll now. I'm running into bumps and fixing them. Let's do the rear. Track offset rear. Same thing we did last time. We're going to duplicate track offset rear as, you know, it's formatted correctly. And there we go. Another little tip. If you undo, so you saw that that was inverted. We're going to fix that while we're working here. This right here, the plus M, is your unit of measurement. It's meters. If you get rid of that, reload the car, vehicle config, tuning, now your ride height is in percent. And with it in percent, the min and max can be inverted. So we invert those, and then reload the car, and our ride height is negative 100%, or whatever percentage all the way up to plus 100%. We're going to go with I don't know. Let's go with negative. Oh, and your step size. Step distance there. That controls how fast this changes. Refresh the menu. And here we go. Each click takes it down 1. 50% up from stock and cambered in ridiculously. Looks really ridiculous. We're going to go 7. No, we said slammed and stanced. Slammed and stanced it is. Cool. Now, enough goofing about. Let's do the rear one. Ride height rear. Our default is 0.288. Our minimum is 0.48. Our maximum is 0. There's no range defined. Our step distance is 1. Now remember, just like the front, the hubs are considered a different component or subsystem from the suspension in this car. So we're going to have to go to the hub's rear, and for the Z value, we're going to use ride height R. And we'll just copy that, paste, paste, paste. Save that. Get rid of that, get rid of that. Control R to reload. Oh, we also forgot suspension rear. Camber. 0.5, 1.5. Reload the car now. Every time I make an edit like that, I'm just doing the quick keyboard shortcut Alt-F-S to save in Notepad, and then I can Alt-Tab back to the sim and check what I've changed. We go to tuning. We should have rear camber should be much more aggressively set, and it is not. So we'll have to look at the front and see what we set the range for. Camber front. Min was 0.5, max was 1.5. Rear. Change our minimum value a little bit. Tuning. So ridiculous. Alright. Rear. Oh. And anything we change in JBEAM, Control R in the sim to reload. Tuning. That's different. So what's happened is the offset's so strong it's pulled the tire up into the unibody and it's making that noise. Alright, let's take some of the camber out of the rear because that's a little too aggressive. Just a little. Alright. Slammed and stanced. Let's put an engine in it real quick and drive it around. Where is it? Put a 2-liter in it. It's slammed and stanced. Now, obviously the values that I've got set here in the sim, these are just ridiculously aggressive. I would hope that, that's understood. This is not a final, I would say, hey, this is a mod, this is how you do it. These are the steps you use to do it. The result that I've got here is kind of silly, but it shows how really quite easy it is to do this. And, that there's these these couple of simple hacks that I've applied can be used for a variety of other things, like the positioning of the engine, the positioning of the radiator. If you do demo derby with multiplayer, you can reposition your radiators now. I leave that exercise to you, but the basic tenets of what I've gone over here today is how you do that. Now, we've got our ride height, we've got our camber. I'm going to fine tune these a little bit here in the menu. So that it's passable as a drivable car. And, you know, maybe looks a little less like everything's scraping the ground. There we go. Now, you'll notice cambering the front end like that has created quite a bit of toe in. So, we're going to adjust for that. There we go. Took all of the toe adjustment it had. The rear axle needs the toe adjusted as well. It's yeah, it's all wrong too. Oh no, I've really messed it up. Let's see. Something's dragging, and I think it's a toe angle thing. There you have it. A stanced, slammed, poorly aligned, strut braced covet. If you've lasted this long, I want to thank you and wish you happy hacking on all of your BeamNG cars. If you come up with something super cool, let me know. Put a video up of it in the comments or something. Because it's surprisingly easy to fall into this rabbit hole and come out with something super cool. And I will leave you with a burnout of my personal car. This is a mod someone else did of a 1958 to 1960s era Nissan 210. They call it the Satsuma 210. And in their kit, they include a rotary swap, which I thought was super cool. I've fitted this one with a roll bar. Now, there is a JBEAM structure for that roll bar, and then there's the mesh for the roll bar. I'm not going to get into doing the mesh in this video because it's a bit out of scope, and I'm barely able to do anything in Blender myself. But I'm going to leave you with the angry chainsaw sounds of a 13B turbo going total ham in a 58 Datsun.